Algebra 2, we're going to do reference angles. I believe these 4 example problems are in the worksheet number 1. So just follow along with these 4. Ignore my mess of a kitchen, and yeah, let's do this. Mr. Snelling did a great job of explaining it, so I'm pretty much just reiterating what he said. So 190, to do that, let's first set up, because I'm very visual, I need to see where it is. So we're gonna set up our graph. So here's 0, this is 90, 180, 270, and then this is also 360, remember, okay? So when we do this, we'll end up about here because 190 is in between 180 and 270. So we're just gonna approximate it. So our angle is somewhere back here. So to find the reference angle, work your way back to the x-axis. So it'd be like right there, right? So you would do 190 minus 180 equals 10. So your reference angle is 10 degrees. The degrees are way easier than radians, by the way, okay? Working with negatives, it's a little trickier. You just have to modify this. It's the only thing, okay? So when we have negatives, this is still 0, but this is going to be negative 90. This is negative 180. This is negative 270. This is also going to be negative 360, right? But because our number is 565, we have to keep going. We have to keep going up by 90. So 360 plus 90, this is also going to be negative 450, okay? This is going to be also negative 540. And this will be negative 630, okay? And so on and so forth. So when we do this, we go around like this. We're at 360, right? We have to keep going around because we have to get to negative 565. So when we do that, we'll end up somewhere in here because negative 565 is in between negative 540 and negative 630. So when we do that, now we have to work our way back to the x-axis. So I like to do a dotted line. So I'm at negative 540. So we have 540. We're working with 540 and 565. So do 565 minus 540, and you get 25 degrees. So your reference angle is 25 degrees for that one, okay? Also, when you do this, ignore the negatives because your reference angle is never going to be a negative, okay? So it's way easier to work with degrees. So on both worksheets, definitely get all of the degrees examples done because I know you can all do that. Radians, I want you guys to all do them, but if you're having trouble with them, it's okay. Like, we'll give you credit for trying, but you need to try, okay? So to label this, we have 0, right? Then we have pi over 2. Then we have pi. And then we have 3 pi over 2, okay? All right, this is where I do it a little differently than Snelling. I just try to make it as easy as possible, okay? So Snelling, the first thing he does is put a denominator on this, right? So this, the denominator is 9. We're gonna make this denominator 9 as well. But to keep it equal to what it was, because remember it was just 1 pi, we'll make it 9 pi over 9 because the 9s would cancel out and it would still just be pi. So I do that, okay? Sorry, and this is also 2 pi. Okay, so when I do that, I can also make this denominator a 9. So instead of 2 pi over 1, you can make it 18 pi over 9, because when you simplify it, it'll still be 2 pi, okay? After I do that, just because sometimes it's confusing to count by 7 pi over 9, you know what I mean, and visualize where in your graph it is, take your calculator, turn it sideways. So do 7 times pi equals, and then divided by 9. This is about 2.44, okay? So this value right here is approximately 2.44, okay? You know that pi, right? Because that's just pi, 9 divided by 9 cancels, so it's just pi. Pi is what? 3.14, right? So this is equal to 3.14, okay? And then 3 pi divided by 2, let me clear this. So 3 times pi equals, and then divided by 2, it's 4.7, approximately 4.71. And then pi divided by 2 is approximately 1.57. So once you convert it into decimals, it becomes a little easier because you know it's definitely 0, so we have 0 and then 1.57, right? So we know it definitely is not in there. 1.57 and 3.14. Our 2.44 is going to end up somewhere in there, right? So we know it's going to be somewhere approximately in here. So here's our angle, okay? And now to get the reference angle, we just have to go to the next x-axis. So when I do that, I know I'm at 9 pi over 9, right? So when I do that, I just subtract. So minus 7 pi over 9, and that'll equal 2 pi over 9. And 2 pi over 9 is your reference angle, okay? Does that make a little more sense? Okay, so what I do to figure out where my point is, I convert it to decimals. I convert everything to decimals temporarily just to figure out what quadrant I'm in. Then once I do that, I go back to my radians and I figured out that I need to subtract our given by the 9 pi over 9. And that's how I got my 2 pi over 9, okay? All right, for this one, so similar, but we have to change, so this is still 0. This is gonna be negative pi over 2. This is going to be negative pi, and this is going to be negative 3 pi over 2, okay? So, what I need to do, negative pi, right? This denominator is 18, so this can also be negative 18 pi over 18. Right? Sorry, I always forget to label this one. This one's 2 pi. Okay, so to do that, remember, convert into the decimals, right? And they're just gonna be similar, just negatives. So this is gonna be approximately negative 4.71. This is going to be approximately negative 3.14. This one's going to be approximately negative 1.57, okay? In your calculator, do negative 19 pi. Well, you could just do 19, just for now, we can add the negative in the end. 19 times pi equals, divide by 18, 3.32 approximately. Negative, okay? So looking at this, you will be able to get, so we would go like this, right? So we pass 3.14, so it'll be in here again, right? Because 3.32 is in between 3.14 and 4.71. So we're in here somewhere. So remember, work back to your x-axis. So we're working with 19 pi over 18 and 18 pi over 18. So just do 19 pi over 18 minus 18 pi over 18. And you're left with pi over 18. Okay, and that would be a reference angle for this one. okay? I hope that helped a little bit. These are, like, unit circle is extremely hard, you guys. It's hard in person, so just try your best, and we'll try and get through it. I hope it helped a little bit at least, and just have a great day. Try and get this done by tonight, okay? Have a great weekend, and I'll talk to you guys on Monday.